Hi, my name's Dick Wall from Escalate Software, and today we're going to take a look at what's new in Scala 2.8, starting with the REPL. REPL stands for Read, Execute, Print and Loop, and it is assumed that you have Scala and the REPL running at this stage, so that if you type Scala at the command line like this, you should see something like this come up. It should be a 2.8 or higher version of Scala running on a recent version of the JVM. If you don't see this, it's best to go back and check this site for information on how to get this up and running. So the Scala REPL, this part is actually nothing new. It allows you to run Scala commands interactively and try things out from anything from simple sums. So we can say 2 times 3, for example. And what we get back is 6, but a little bit more information. First of all, it assigns it to a variable called res0, which we can now see and use. So if I do res0 times 10, we get 60. And also it tells you it's a type int. This is Scala's type inference system, which works very nicely. But we're here to have a look at what's new in Scala 2.8. The first thing to do is to use :help to see what is available. There's a bunch of new stuff. The new ones that I'll point out are CP, which allows you to add things to the class path. It allows you to add jars or folders to the class path, and this makes it easy to import classes that you want to try out. Also history. This gives you a list of the commands that you've already used, and you can search that history using H question mark. So if I go and say H question mark, and let's say 5, it'll show me everything that I've typed that has 5 in it. Very useful. Other stuff that's new. Actually, load is not new. Load allows you to load a file, and replay allows you to replay that file. We'll see that shortly. There is a power command now, which allows you to enable power user mode. And we won't be going into that in this screencast, but a future one will deal with some of the features in that. And then there's a new one called :sh, and this is very useful. This allows you to run shell commands against the host operating system. In this case, I'm using Linux, but this will work the same on the Mac, and it will work on Windows, although you may have to use dir instead of ls. But let's see what happens if I type shell ls. What it does is brings back a list of the files in the current directory, but it's quite useful in that it's actually a Scala structure that comes back, a list in this case of strings, and it's also been assigned to studout here. So we can actually now use studout as a collection to perform operations on. So I can say studout for each println, and it will print them out. I can say studout map, and then underscore reverse, and it will give us those strings reversed. Don't worry too much about the syntax here if you don't know it yet. This is just to show you that what we're actually doing is reversing the strings that are represented by this thing. Okay, so that's pretty nice. Let's see what else we can do with the REPL. I can use the shell to gedit a file that I've got. You see up here I've got one called fib.scala, and so let's load that in using gedit. And let's move it into the window here so you can see it. And this is a Fibonacci method defined in a file. All it does takes an integer, returns a long. You have to specify the return type because this is recursive, and then it does pattern matching and gives you back. This is a pretty typical implementation of Fibonacci. If we've got a 0, the result's 0. If we've got a 1, the result is 1. And anything else, we give back Fibonacci of n minus 1 plus Fibonacci of n minus 2. Pretty standard stuff. So, okay, let's go ahead and load that in. So you use the load command for this, fib.scala. And we've now got that. I can now type fib8, and it gives me the 8th number in the Fibonacci sequence. I can use 1 to 20 map fib, and that will give me the Fibonacci series from 1 up to 20. I could do that from 0 as well. Let's do that. Okay, so great so far. Everything's working. Now what happens if I type Fibonacci minus 1? Okay, my application or my definition, depending on how you look at it, has a bug in it. I would say a Stack Overflow error is a bug. Basically, this is recursing, but it's recursing from -1. There is no termination condition. It's just going to keep going until it runs out of stack space, which it did. So let's go ahead and fix that right now. So we'll bring up the editor again on the Fibonacci.Scala. And what we're going to do, we're just going to put a condition in here that says require that n be greater than or equal to 0. And if it's not, we'll say n must be 0 or higher. And save that. Okay, now, instead of just loading that in and doing it all again, what we can do instead is actually issue a replay here. And what's going to happen is it's going to run through all of the commands that we did in this session. So don't worry too much about the... it doesn't pick up the shell command again, because that was a colon command. So those ones are error conditions in this case. But don't worry too much about that. What we're interested in is the Fibonacci here. And so what we've done, loaded it in again. It's replaying the test of Fibonacci 8, which is 21. It's replaying the 1 to 20 and the 0 to 20. And now we can type Fibonacci -1, and we get a illegal argument exception, requirement failed, n must be 0 or higher. So we fixed our problem. This is sort of like a poor man's unit testing, but it is extremely handy for just trying things out. The REPL is very, very useful for that. A couple of other features that are in the REPL now, which are absolutely invaluable time savers. Probably the biggest one is command line completion. So let's see that in action. Okay, so let's start with a nice fresh session, and let's start Scala again. So another new feature in the REPL, a very nice one, is built-in code completion. This is really handy when you're exploring a new API or something like that. But let's take a look at a simple case of this. So let's say hello world. So we're creating a string called S that says hello world. What we can do is type S and then dot and hit tab. And what tab will do is give us all of the methods that can be used on S. So you can see here we've got all of these string methods. Let's try some out. So let's say we want to get the length. So we can type s.len and hit tab, and it completes it for us. It's very nice. So now we see that the length is that. We can say s.to uppercase, and we get the string as uppercase, and so on. It actually goes quite a bit further than this. So if you're looking around packages and you want to see what classes there are, you can, for example, say import Scala dot, and I know it's collection, so hit tab and it completes it for me. Dot, and let's see what's in the collection package. So the collection package has all of these defined for us, but let's say we want to see what the immutable ones are. So we hit immutable, IMMU, hit tab, it completes it for immutable, and then we can see, hit tab again, we can see all of the classes that are in immutable, and similarly, all of the ones that are immutable. And, let's do that again. So tab, and it shows us all of the classes there. So the command line completion, this can be used in collaboration with things like the class path and the import of individual classes to explore a new API interactively. And it's just a terrific way of doing it. And don't forget, if you want to see what you've done to this point, if you solve a particular problem, you can simply type in history, and it gives you back the history of the commands that you've typed. So you can then take these and put them into your program. The REPL. It's good for your productivity.